Hello everyone, I am Noor Zainab and in this video we're going to solve some examples and questions related to the series combination of capacitors. In the previous video I derived the equivalent capacitance of the series combination of capacitors, so you can watch that video also. And now let's get started. The question number 1 is: find the total capacitance of three capacitors which are connected in a series combination, given their individual capacitances are 1 microfarad, 5 microfarad and 8 microfarads. So by applying the formula of the equivalent capacitance which we derived in the previous video, we can find the equivalent capacitance of these three capacitors simply by putting their values in the formula. By adding all the values, we get this answer. In order to find the equivalent capacitance, we would have to take the reciprocal of both the sides. So by taking the reciprocal of both the sides, we get our answer, which is the equivalent capacitance of these three capacitors. So when finding the equivalent capacitance in case of series combination, don't forget to take the reciprocal at the end of the answer. Now let's solve the question number 2. Three capacitors of capacitances 4 microfarad, 6 microfarad and 8 microfarad are connected in a series combination to a 250-volt DC supply. Find the total capacitance, number 2 charge on each capacitor, and number 3 potential difference across each capacitor. So what we have been given? We have been given the value of capacitances of the first capacitor, second capacitor and third capacitor. We are replacing the prefix micro with 10 raised to power minus 6. And we have been given the voltage V, which is 250 volts. First of all, we're going to find the total capacitance of these three capacitors. In order to find the total capacitance, we will apply the formula which is for the series combination of capacitors, and by putting the values, by adding all these things, by taking the LCM, we get the final answer, which is 13 by 24. This is not our final answer. In order to find the equivalent capacitance, we would have to take the reciprocal of this. So by taking the reciprocal 24 by 13, we get the answer 1.844 microfarads. This is our equivalent capacitance of these three capacitors. Now we have to find the charge on each capacitor. So as we know that it is a series combination, and we can find the charge Q by Q is equals to CV, where C is the capacitance and V is the voltage. Value of equivalent capacitance we have derived right now, and the value of voltage is given. So by placing the values in the formula, we get the charge Q which is present on the capacitor. As we know that it is a series combination, in the series combination the charge which is produced on each capacitor and the equivalent capacitance are equal. So this same charge Q is produced on each of the three capacitors. This charge is same on each capacitor as well as the equivalent capacitance, which is the total capacitance of the three capacitors, is also same for the three capacitors. So we can say that the charge on Q1, Q2 and Q3 is same, which is equals to Q, and which is equals to 460 microcoulombs. In the third part of the question, we have to find the potential difference across each capacitor. So as we know that Q is equals to CV, and from this formula we can find the value of voltage, which is equals to Q divided by C, where Q is a charge and C is a capacitance. So we know that in series combination the charge Q is same on each of the capacitor, whereas the capacitance is different on each capacitor. So that's why each of the capacitor has different potential drop. So now if we find the potential drop across each capacitor, for the first capacitor with capacitance 6 microfarads, we will put the values. The charge Q is same, whereas the capacitance is different, and by dividing we get this answer. And in the same way we will find the potential difference for the second capacitor as well as for the third capacitor. So here you can clearly see that the charge Q on each capacitor is same, whereas the capacitances are different. So that's why the potential difference across each capacitor in a series combination is different, whereas the charge Q stored on each plate of the capacitor in series combination is same. So now let's solve the next question. You have 50 identical capacitors, each with a capacitance of 1 microfarad. You have to determine the equivalent or the total capacitance when all the capacitors are connected in series combination. So As we know that the formula for finding the equivalent capacitance is this, but the question is mentioning that the capacitors are identical. It means if the capacitors are identical, they have the same capacitance. So for identical capacitors with the same capacitance, the formula will become like this for series combination. Here N denotes the number of capacitors and C denotes the capacitance, which is same because the capacitors are same. But for parallel combination of capacitors, the formula will become like this, where N is the number of capacitors and C is the capacitance, which is the same. So now for this question, by applying the values, here capacitance is 1 microfarad, whereas the number of capacitors is 50. So we put all the values in the formula and we get this answer. But in order to find the value of equivalent capacitance, we have to find the reciprocal. So we will take the reciprocal of both the sides, and hence we get 1 over 50 microfarads, which is equals to 0.02 microfarads, and we can convert it into nanofarads by simply multiplying it with 1000. And hence we get our answer, which is the equivalent capacitance is 21 nanofarads for 50 identical capacitors which have the same capacitance of 1 microfarad. So thanks for watching, and like, share and subscribe to my channel for more videos, and if you have any questions you can ask in the comment section, and thanks for watching.